Oh, no. Is it working now? There we go. All right. This is Flex. Yeah. Flex. You know, these were like really expensive DJI mics, and they're more difficult to use than my cheap set of Hollywood mics that I've had. All right. So yeah, this is flex fuel, KV8, et cetera, et cetera. We're gonna start on pump gas here. Haven't really done any tuning to it yet. It's just been startup stuff, get the gauges working, all the stuff working. I haven't tested vehicle speed yet. It wasn't working before. I just changed the settings a few minutes ago. Uh, but it's dishwasher sound, believe me, the audio's bad. It's got solid engine mounts, solid everything on it, so it's pretty. There's a lot of sound carried over, unless my other mic is picking up with out there. It is. Okay, it's weird. Maybe this will help. We'll see. I'll put them both in here. Let me know if that's any better. Okay, so let me get the EMtron fired up here. Like I said, I've done shifter tuning. I drove around the block, basically just worked on getting all the electronics to work in it. Um, that was that was my ultimate goal with the initial stuff. Is that better? Okay, good. Yeah, all right. Apparently the mic, even though it was in its stand and charging, turned itself on. So, fuck me. Alrighty. Any desk. Oh yeah. Let's get the dyno set up on here. Okay. It is 38 degrees. It is right about 60% humidity, and that is our height elevation. Okay. I can fire penny desk and get that going so we can see the dyno stuff. Then we're going to start having some fun. This car is going to have multiple fuel models. I do need to set that up. I haven't done it yet, so I'll get to do that for you guys. You get to see me set the different fuel models. The idea is that I'm going to have different fuel models on one of the buttons on his keypad. It's got an EMtron keypad. So you'll get to see that get set up, but that's super simple. The keypad is like plug and play, literally just plug and play on these things. Um, so we'll get that set up and we'll have the other fuel models come up as well with the buttons. So the idea is that um, we have this system running in TMAF. Okay, now TMAF is throttle mass airflow. That is a fuel model that is kind of proprietary to EMtron in the aftermarket world, and Bosch in the OE ECU world. So I don't know if there was some copying going on, if it was just philosophical thing, you know. I'm not sure what made um, where they got it from, if they're the same, different, or what. But the idea is with TMAF, the sensor throttle mass airflow, that it calculates the mass of airflow through your throttle body using the size of your throttle body, the percent of the cross section that is available to airflow, and then the pressure and temperature on both sides. And so if it knows the temperature and the pressures and knows the size of the orifice, it knows how much flow is moving through that hole. Now, you can think about that and be like, oh, that makes sense, because if I know an orifice size and know pressures, then it's going to be, a certain amount of flow. The issue that you may have with that is when the throttle is wide open and the pressures are the same. So when the pressures are the same, you no longer get the equation falls apart if the pressure ratio is 1. Um, if the pressure ratio is 0, then that's infinite and that's no fuel. But if the pressure ratio is 1, it also falls apart. And so what they have is a calculation and some compensations that you can adjust to make it read correctly at that point. Now, that being said, I don't use TMAF all the time. I use speed density as well, and I also don't use TMAF as the sole fuel model for the calculation. Right now, I have it set 50-50. Half the calculation is TMAF, half the calculation is speed density. Is that better? I don't know. I don't think so. EMtron would probably tell you no, it's not better to do it that way. They want you to bias more heavily towards one in certain situations. And based on how this car behaves in the end, I probably will bias more towards one versus the other, but it depends on how everything works. Now, those are the two main fuel models that we'll be using, and those are blended. I do put in a fail-safe thing, which will be available on the keypad from the press, and that will put it into a TPS-based fuel model. It takes a while to set up. That one takes a while. Uh, so right now, my main goal is to work on getting the TMAF correct, getting the speed density tables correct, so that if it's when I will put it in 100% in one mode and then 100% in the other mode, get those dialed in, and then do it. Now I don't have to do it that way. I can leave it at 50. I can leave it at 50. Um, the the fuel model calculation is displayed on the EMtron software. It it'll basically what'll happen is if it blends 50, then I know that half it's from one, half it's from the other. If the error is like, well, let's say I have 15 and 10 grams per second on one versus the other, and my air fuel ratio is spot on. Well, then I know that the final calculated air mass was correct. And I know that that was 12 and a half, right? It tells me it's 12 and a half, but I also know that because 10 to 15 in the middle of that, 12 and a half. So then what I would do is I'd make the adjustments so that both of them were then 12 and a half. And so I don't have to go all the way 100% on one and all the way 100% on the other to do it. All three are displayed, and I'll show you that right now. So in the EMtron software, if I'm going to my tuning section when I'm tuning, right now I'm in idle control. You see our idle speed go up and down here. Now that's 930, that's 1074. So that's not too bad for something with 1700 cc injectors that were not made for pump gas, running on pump gas. So I can't bitch about that. That's pretty good. But anyway, so we go to fuel here. We'll say VE table. So here's our VE table that I put in here. It's the base one. And we'll see the blue line is the TMAF calculation. See how smooth that is? Because the throttle plate's not moving. Okay. Then the green line here is the map calculation. And that's jagged because we're seeing pulses in the intake manifold. And changes in speed. And changes in speed move us over here on the VE map, and that adjusts what our map air mass calculated is. Okay, now you can imagine the bigger the pulses, the more that's going to mess with this calculation, the jitterier it becomes, and the more it can mess with your fuel. And that's one reason that the TMAF is good, because look how stable that is, right? That's as stable as can be. Idle just changed because the fan kicked on or something, right? Nope, 168. Fan did not kick on. But either way, you can see how stable that is. And that helps the engines run more stable. Now, here we have the purple line, you can see it in there, and that's a blend of the two of them. It's going to be jittery because the green's jittery. One of the inputs of this is jittery, one of the inputs is stable. Overall, it's going to be jittery with the green. And actually, right now, I might be fully on map. Let's find out. Let's take a look. Nope, I'm 50-50. A little less than 50%. See right here, the zeros really close. We're blending into this zero smidge. So if I went like this and went 100, okay, Now what we'll see is um, our air mass flow final is 5.2, and our Tmath is 5.4. Well, hold on a second. That's supposed to be 0 and 0. That's supposed to be the exact same. Huh. That should fall right on top of it. That should be the exact same now. Now it's not. Now I'm seeing a little bit of difference in there. I should make sure that I don't have something else set funky. Now these things do also have a calculated, let me show you here, calculated setup, our efficiency, okay, that's fine, that's good, all right. Uh, Air mass, speed density plus throttle mass flow, yep, that's correct. Using the speed density and throttle mass flow, note the correction table can be used to turn the calculation rate correction required, blend 0, all speed densities, blend 100, all Tmath. Yep, okay, that's correct. Speed density, we're going to blend at the 2V tables. And that's going to be based on um, ethanol. Throttle mass flow. I have one drive wire throttle body playing into the calculation. That's good. It is 60 millimeters. Right now I have the filter mode as EMtron default, but we can change it if I run into any issues. Outflow scalar is 24. That's what I'm talking about. I see how with the throttle is wide open and the pressure differential is 0. It's the same pressure on both sides. That's what this is about. We don't have that. Before plate, boost pressure, that's correct. After plate, manifold pressure, that is correct. And the temp, that's correct. Okay, all that is correct, but that is really weird that it's not exactly the same. So throttle bar area table. This is the table that says how much of the area of the throttle body is being basically exposed to airflow, and we do small tweaks on this to get the correction or the correct calculation. This is the outflow correction table. This is, there's that 24 you saw in that one for the outflow. This, I can make this table bigger, and then I can add small bits of correction where they're needed under full throttle if needed. It's rarely ever needed. And then this was the, oopsie, this was the, gosh darn it, this was the filter, which is set to default right now, so that's not there. Oh, sorry, this is the outflow correction table. That's the one. This one is the total correction table for small corrections that you can make anywhere in the TMAF. And this one is an outflow at wide open. So um, these are the torque tables. These aren't affecting what we're going to right now. Here's ignition, here's fuel. But that's weird. When this is at 100, it should be all TMAF. This air mass flow final should sit on top of this, unless there's a compensation that's being applied, then that would actually change. So I guess I forgot about that. But see, there's smoothing in here. Look at that. See the step, and then there's a smoothness in there. So the smooth is the throttle, and the step is the final calc. But you can see how flat it is, right? At least you can see how flat it is and not jittery. And if I go the other way, if I go to 0 here, now we can watch that purple line is actually under that green line here. It's tracking it very closely. So the reason the purple's not hugging that TMAF is because there is a filter on the TMAF. Uh, and that filter is apparently pretty strong. And the reason for that filter is this. Watch this. So I gave it a rev. Now, you'll see here the map is the highest one here. It used to be the other way. It used to be on TMAF. This TMAF would go 4 or 5 times higher than the map calc. And so they had to add some filtering to it to keep that happening. And you can see here it's actually more than the map. But that doesn't mean it's wrong. That map could very well be wrong because I haven't tuned that part of the map yet. So um, the TMAF might be perfect in this spot. But one thing I do like, they're responsive. You know, they're responsive with these fuel models up here. And then the last one will be TPS. And with that, I will set up um, uh, let me think about that. How did you look for? Yeah, I'll have to change the way this blending works here between the two V tables. It's not a concern right now though. I'll do that later on. But first, I just need to work on these. Need to get these going. Okay, I want to see if my speed works too, because speed didn't work before. I made some changes to the calibration. Still doesn't work. It's not working here either anymore. What the heck? What the hell? So now my inputs for speed aren't working. Huh, that's weird. It worked a few minutes ago. Now it's working. I didn't change anything. I just hit OK. That's got to be a bug. See, there's some sort of bug on that. Sure enough, speed's working up here. Hmm, not liking that. That's going to be annoying for the customer. I'll have to talk to EMtron about that, see if there's something I need to do. Oh, let's hit this one. It could be this guy right here. Yep, it's that guy right there. Oh, that took a long time. Okay. All right, so I've got speed on the cluster. I've got gear. Was I in first? No, I was not, though. It said I was in first. Here's second. Says gears 2. Then it says gear, oops, it says gear 5, yeah. That says 3, 4. All right, it's working. 5. Yep. Okay. Yeah, that works. Good. Okay. Set the tack on the dyno. Somebody else's car. Now, see, look right here, right? Look at that separation between the throttle and the map. So, which one is it? Well, I'm seeing here my short-term trim is minus 10%, and my throttle is low and my map is high. So that leads me to think that the problem is the map. Well, that was crazy. So that really switched at RPM right there. Look at that. Wow, that's a as RPM climbed, that completely swapped over. So really quick, I'm gonna go look at my cams really quick and see if they moved a bunch right there. Nope, they were steady through that area. So that tells me it's VE table thing. Um, yeah, look at that right there. So that peak is too high. That's fine. Like I said, I didn't even, this is a base map for another car. I just threw the fuel map on here really quick. So that makes sense. So right here, we're looking at the map is high. That tracks, right? Like that's 76. is probably more likely to be true than the 83 right there. Oh, one more thing I gotta do, actually. I need to put the exhaust pressure back in it. I took that off because we were troubleshooting stuff before. I need to put the exhaust pressure back in it and set this fuel table up for pressure ratio. So exhaust pressure used to be right there. They moved it over here now. Okay. So here's our exhaust pressure, 100. So we got a little bit of restriction in the exhaust at this point, which makes sense. We're at 25. There's a little bit turbo restriction in there. See it climb positive right there. Okay. I don't like the fuel pressure at high idle, the oil pressure at hot idle on this. I don't know if that's a function of the sensor having air in it, uh, the sensor calibration being off a smidge, or what. But it says 15 psi right now at idle. Now, I've never actually had one spin a bearing at idle for having less than 20 psi of oil pressure at idle, but that just feels low. Just feels low to me. I don't know what the fuck this dude is doing. I don't understand why he had to do what he just did. Why didn't he just back up further? I was about to hit a car. That was close. So, I don't dig how low the oil pressure is. I wish it was higher. Um, some of this could be from a lot of fuel dilution, from all the problems we had before. And as I run it and the oil gets hot, we clean it up. It may go back up. It actually may go up as we start loading a little bit. And it may go down with temperature, so we'll see. It would be a good time to double check my oil pressure sensor calibration and see where I'm at. So this is set up as a TI-150. I know it's a 150 psi sensor, but I don't know if that's the calibration of this sensor, honestly, because this is a Rife oil pressure sensor. I should double check that, see if that's even correct. So I'm gonna look up the Rife temperature calibration or pressure calibration. Rife 150 psi sensor calibration. You can't see what I'm doing because I'm on the internet and that's not being shared. Pressure 150 psi. So at half a volt, I've got 0. At 4.5, I got 150. That's the calibration I got. Pretty sure that's what's in here. 0. That's in kPa. Let me double check their kPa measurement. 1034, 1034. So that's the same. So that is the same. I mean, that's assuming it's a 150. It might not be a 150. I think it is. I don't know what else it would be. It's stamped on the sensor. Double check real quick. 50, 150, 150. Okay. I swear, with these mounts, man, with these solid engine mounts and the small solid pitch stop mount, the engine is quieter in the engine bay than it is in the car. Okay. All right, cool. It's on top of the block. Should be, yes, it is. What oil weight? Yeah, I think it's 40. I think it's 40. Okay. Back to where we were. Back to tuning. I want to put the pressure ratio back in this. So I'm going to select this guy. Oh, I screwed that all up. What is going on here? I went the wrong axis. Okay, cool. Duh. You see how much it didn't care though? Like the engine didn't hiccup for a second. It didn't even bobble. Nothing. It's, there, that time it did. That time it bobbled a little bit, but the last one didn't. Okay. All right. Let me go to V table 2. And I'm actually going to take one and double check my Z axis on it. Nope, I want this guy here. Right there. So mostly on 1, or 25% on 2. Okay, so we'll go to 1. Shift Control C. Escape down, enter, Shift Control V. That puts us on 2. So let's go on there. But what I'm going to do now that I got that done, I'm going to set this all to 1 for this portion of the tune to make sure that I'm only messing with this VE table as I'm doing it. All right, so now I put that back on map versus EMAP. That's how I originally had the map set up. That's what this table is actually from initially. I just swapped it over to pressure really quick because we were having issues with hooking sensors up and stuff. But now it's good. And now it's actually on the other side. We're actually a smidge light on the map calculation. You see here, it's a little on the low side, which makes sense because 51 is a little low for that. That's a little low. 55 would be much closer to what I would expect to see. Even with my cams, actually somewhere in the 55 range, even with as big as they are, that would make way more sense to me. And then our model is what? 50-50 right now. So if I want to just really quick, like I said, I go 100, that's all TMAF, or 0, and that's all VE. Go to here, look what it goes to. It's adding 5%. You see here the total calculated and the map are the exact same line now. And the throttle is a smidge low. So the throttle one needs to come up a little bit and the map still needs to come up a smidgen. So let me turn that off so I can see my tail better. We're going to go right here and do this a couple times. I heard the tone change even of the engine. That's pretty crazy. Yeah, but you know what makes sense about that? 1700s don't do well on pump gas. Even though we're at point 0.9 lambda, we're not even at 14 to 7 to 1 because it wouldn't run very well 47 to 1. We still have cylinders that are leaner than other cylinders because these injectors are um, they're not tracking really well down here in this low pulse width. Doing way better than like an FIC injector would be doing, but still needs a little bit of, it needs a little bit of help down here. So to help them out, we do a slightly longer pulse width and call it good. Throttle body model. Let's go throttle body model. You can see here that our throttle body mass fuel number is lower than our calculated, so I'm going to add some to it. Just kind of a little bit like that. That's it. That might be too much even. That small adjustment might be enough. Oh, I didn't move much. Yeah, let's swing it back here again. I take this and go to 100 now if I wanted. Again, if I wanted to just adjust each one individually, I could do it this way. You go back and forth. Um, but this would take forever to do pulls with and do that, etc. So what we're going to do instead is just leave it at 50 and then split the difference when I'm adjusting stuff. So here we see that our fuel trim is pretty much right on. It's pretty close to right on, but we'll see that our target is actually richer than our current lambda. And we can hear the engine, I can hear, I don't know if you can, just starting to misfire a little bit, right? So here we're at 0.96 lambda. So we've leaned it up almost a stoic, and that's when I hear the misfire start to happen. Pop, 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 pop. One of the cylinders, maybe two of them, just aren't getting the fuel that they need. That pulse width from the injector is so brief, it's so small that it just has no time to atomize and stuff. Now both his fans just kicked on, um, and this thing gets mad when the fans kick on. It was even worse on the Haltech. The thing would almost completely stall because they're both wired together for some reason, and they come on together, and the voltage drops to like 10 volts when they kick on. It's pretty crazy. So that's something that's going to have to be worked on at a later time. But right now, we got to get this freaking tune going. So yeah, so we can see that we're a little on the lean side of the target, and my correction was really, really lazy down there. So I can go to my lambda control and see why was it so damn lazy. Okay, well I got a 0.002 error that I am allowed to have. That's a dead band. That's fine. Proportional, really low right there. Look at that. It's a really low proportional value. So the reason for that, the reason I have it so low right now, and why it will probably stay pretty low um, during the whole thing, is the transit time from the engine to that sensor is not instant. And granted, I have that table right here, this transport delay, which I do need to adjust and work on and get right. Um, there's still, I don't want to have a big proportional in it because if that transit time's off a little bit, then that proportional is going to be based on the instantaneous error, which means I could induce oscillations with the proportional. So I want to rely more on integral, which is error over time. And oh, look at that. Lo and behold, the integral is really low right there as well. So that explains why it took so long to make up that gap that it had earlier. So I bumped this up a little bit, and now it's going to try and hug this a little closer and be a little more aggressive. But in order for there to be correction, there's got to be a little bit of error. So we're going to be up a little bit. Plus, I got that 0.02 error allowed in it. So um, derivative, that's fine. That just minimizes how quick it's allowed to change. And also, it also affects um, as it departs from target, it changes the correction like immediately. So that helps to provide some stabilization. But all in all, we're still about 5% lean. So we can go back to our TMF table, our throttle body model, and we can add a smidge to it. Bloop, like that. So that was another little bump. And sure enough, look down here, and you can see that this green line popped up and got closer to the yellow line, which was already really darn close. And I could just click main right here too if I want. I'll have to have it on throttle body model right there. Click it here, and sure enough, now we're on the rich side. And oh, we're right there at target lambda now, and we're at 2%, so that's pretty close. That's pretty good. All right, so now what we're gonna do is I'm gonna set the dyno at a fixed RPM, and I'm just gonna start loading it and going through some spots. I could do a sweep, do a low speed sweep or a low throttle sweep through the whole map and just see how far off the whole map is. Whatever technique you choose is up to you. So a little bit of MVH, yeah, there's a lot of MVH in here for sure. But it's a race car, so everything is firm. And he's got the shifter that I don't like. Um, but the shifter works better when you have solid engine mounts. So that helps with this. Then stock engine mounts with the CE shifter is a fucking nightmare sometimes. So, but his is actually set up really well. Every other CE shifter that I've been in, they take so long to set up, and even on the setup, they just don't work quite as good. But his seems to be working pretty well, and I'm guessing it's because of the solid engine mounts. There's so little room on this shifter for any error in the location of the shift linkage that bouncy mounts just make the shifter like not even usable. Um, Not a performance thing at least. Like, yeah, CAE, yep, yeah. It's usable in like the street if you want to be a fuckboy, but in a race environment, this thing is not fucking usable if you have engine mounts that aren't hard as balls. Which he does. He has the mounts that are hard as balls, so it makes the shifter usable. But Otherwise, I cannot stand this thing. But his is the best setup one, or the best functioning one that I've dealt with, and that's probably because of the stiffer mounts. Group N, and yeah, see, and all the ones I've been in, the Group N is not strong enough. But that's only been like 20 cars. Okay, so right here, we're in that same spot now, right? Like the map is high. We're pulling fuel. Total calculated is high. So we can see that this says a 10% difference of fuel trim, but we can look at this and go, 10% from 18. Wow, that's close to that. It's not exactly that. That means the throttle's a little low and the map is a lot high. Oh no, the map is 20. So yeah, almost right in the middle there. Let's double check my thing here. Did I put it back at 50? Oops, wrong one. I didn't. Oh yeah, I'm at 50 now. In this spot, we moved up into this 50 zone. So that's good. That means that really the difference is just my speed density one is too tall. Too much on the map right here. And so if I change this map, I'm bouncing on the tires right now. Wah, 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 wah. So you see you go down, you see the green line starting to drop, and the purple line is getting closer to the throttle line. I'm gonna do a little blendy here because I know that I'm gonna have to adjust all that in a minute. Let's go down some more. Now this number is starting to get a little lower than I want it to be. Mid 60s is about as low as I want to go. If it's less than that, then that means I need to, oh, look at that. That means that it's probably going to be like a small injector setting that needs to be tweaked or something, along those lines. But no, look at that. Now that green line's dipped down, so it is a lot closer to the throttle line. We're still rich though. Still rich by quite a bit. Um, which means the throttle line's probably a smidge rich as well. So let's go look at that real quick. Let's look at our throttle body line. Okay, we're in this spot. That's a decent sized jump right in there. You can see here on the graph on the right, it gets steep right there all of a sudden. So maybe we just take a little bit of that right there and make the graph a little more gradual before the steep section. Then we go back to our fueling. The throttle dropped. Open that gap up to the map. We're pulling less fuel again, so that's good. Now, like I said, this is getting low. This 64% is getting pretty low. Um, I feel like I might need to adjust a low pulse width setting on the injectors or something, even though these are a fixed. And I might need to adjust that a smidge because I don't think that I should be pulling this much fuel out of the map right here. What's our pressure? I mean, we got some good vacuum, but still, that feels low. Okay, RPM's a little higher. Same thing. Right now we're at 3,500 RPM. Map is now less than throttle right here, and we're still rich. What's my throttle at? Now, see if we find, yeah, see we're at a higher zone now by a little bit. So it looks like we're gonna be a little more gradual on the throttle and then a quicker ramp into this midsection. So my guess, if I have to just pull a little bit more down right here through this section to get it accurate. Now I have such a low throttle input to it that I think I was tripping idle control a smidge. Boy, she's snappy though, let me tell you. This 2.3, I drove it down the street, and even just driving down the street, I was like, oh, it wants to go. It does not feel like a 2.3. It sounds like a 2.3, but it doesn't feel like a 2.3. It's got torque, it's got well, they all have throttle response, they're 2.3s, but it's got that low end throttle response that you don't always see with a 2.3. Um, Granted, this one's got pretty high compression, if I recall correctly. All right, we got some separation here between these two. So let's go back to our fuel V table, look at it. Throttle's the high one now, and map is the low one, and it's adding fuel. So I got to add some to the map, which makes sense. What's that say right there? 58? Yeah, so I'd expect that. There we go, it's closer. Look at this correction. Stays within. Oof, this sucker's got some torque. That freaking 825 wants to go. I think it wants to go for sure. All right. So we're pulling some fuel up here. Throttle's the high one still. Again, let's go to throttle body model. Yeah, we're in this zone right here, so pull some out of here like this. We're just making this a little flatter. There. The colors are different on this screen. God damn it. Throttle's low on this one, but we're pulling, so it's actually the map that's high. It's a different color than on this screen. They're reversed. Okay, yeah, that makes sense. That's a big mountain right there, VE. Not sure what key I hit there. I hit something that was a shortcut I didn't know existed. Right. Oh no. DCCD is slipping. Felt it. Oh yeah, big time. Yeah, what's he got for a DCC controller? I don't see a light on here. That's not working. There's no light coming on in this controller. Uh, I don't see a controller in here. Nolan, you're in here, right? You're in the chat. What do you use for DCCD control? Carboy Tallboy discussion. Fuck yeah, I do. That's what I run. Put my short shifter with an extension and weighted knob. Well, yeah, you shouldn't have a weighted knob on your car. Weighted knobs are junk. Have that on those big jobs. Love to hear it. Compression will do that. What would you have to spend to do 2.3 with the right way without cutting corners for 6 7 wheel horsepower? Long block, not mods. I mean, basically this right here, this car, he did right. So just ask Nolan. You got a controller in here, dude? Okay, I'll put the dyno in a different mode to try and get it to control wheel speed better. Oh, I got it on the strongest mode I got. We could try this one. Sometimes this works. Watch this torque split when I start to accelerate. I mean, you expect a torque split. Oh, that works better. Okay, speed staying the same. Yeah, that's a lot better. I'm not getting that speed difference. That's good. So this is, oh, that's big right there. It's off right there. Let's go right there. There we go. Now they're hugging each other. This one's a little light right here. Add a smidge right there. There we go. Now it's hugging. See how close those lines got now through here? Look how far it was off, then it popped in. Going with right here. Now during throttle transients, you're going to have differences. It's steady state to steady state that you got to work on this. Here the map is low and the throttle's high. Map is low, throttle's high, but we're rich, so the throttle needs to come down. If we look at our model, though, we've been in this zone already a few times, and that means we might need to actually resort to adjusting one of the TMF adjustment tables, trim tables. Because if this zone happens all the time, and every time we're here, we get this skew, or it could be we open up, or this is just too steep. Oh yeah, look how big that is. This could still be too steep right here, which is totally plausible. That happens all the time. This right here can be too steep. This could be too high. This needs to come down some more. And it's looking like that's to be the case. Look at that difference, that error right there. So we'll keep bringing that down. Now this table was provided by EMtron, but every car is going to be different, and every I call it T-map sensor, but this one doesn't have a T-map. This is just a map sensor by the throttle body. The placement of that sensor is going to affect the result. Um, if it's really close to the throttle body, or if it's in a pipe that's a different diameter that steps up to go into the throttle body and there's a small pipe, there's going to be a pressure difference between the inlet of that throttle body and that pipe right there. And that'll make it not correct. And so the standard calibration won't be accurate. You have to change it to make up for that. So um, those types of things will definitely mess with it. So it's important to understand that placement of that sensor is vital for the system to work correctly. And if you don't put it in the right spot, you got a lot of tuning ahead of you. And in some cases, you might not be able to tune it. You might not be able to get it to work right. So putting that sensor in the right place is important. Okay, we're getting closer. See, it's getting closer to the map through this region right here. The lines are starting to match up better. And our short-term field trim is pretty small. So it's getting pretty close. And that's good news for us. Okay, coolant temp you see up here is 190, so it's not even close to being hot yet. Oil pressure, though, is 55 at 2500. Look at that. So those are getting closer. And you see it's pulling 2%. The throttle's below 1 and map's the high one. So now the map's actually got to come down. So we've got the throttle about the right spot now. So that spot there, the map's got to come down a smidge. By map, I just mean the map calculation. which is the speed density table right there. Look at that, right on top of it. Airfield trim is almost nothing. Yeah. She's snappy. She's so snappy. I'm so snappy. You already know. If this is, oh, this is gonna be too much, right? Like, what are the odds of it being that high at this low RPM and then being different here? Now, cam timing, like I could tweak cam timing right here and find out that I had it not in a good spot, and I could tweak the cam target there, and all of a sudden VE goes up much right there. Uh, so that was a cam timing of about 40, 45 degrees, which might be too much for that zone. I guess we're right here, huh? That might be too much. It might not want that much timing, and so we're losing some VE from it. So let's take this down to 30, and then do it again and see how far off that the fuel is now. Hopefully, now it's got to add fuel, which means we've added air. Help you out on the fuel section so you can see. It's adding 3% there now. And the map is low, so that's good. So yeah, the previous timing was too much on the cams, and by retarding the cam some, or less advanced on the cam, we actually increased airflow, which is not hard to believe at all, because 45 on a cam this size, uh, or 40 degrees on a cam this size, in that region is a little aggressive. Would not be outside of conventional wisdom to think that the engine's moving too slow and I'm pushing the air back out the intake. Or I'm sorry, no, in this case, uh, I'm just retaining too much exhaust gas in that case. Rich right now. And now I got to add some throttle back into it, apparently. So my VE was off, but it should compensate for that on its own a little bit. All right, that's really close. That's really tight. That's really tight. Okay, I'm gonna do a sweep to get these higher RPMs. It might be unplugged. Oh, the DCCD. Oh, sure. Yeah, okay. That would make sense. 12 to 15K, what, miles? That's all it's on this thing? That's crazy. All right, I'm gonna do a low throttle sweep on it. So low throttle pull. Oh, let me make sure my wastegate duty cycle is 0. I have no idea if I set there or not. I should have. Boost control. Otherwise, I'd be chasing my butt. Yep, 0. Okay, cool. Chasing my tail, trying to keep the boost down. Yeah, let's do this. Let's put it on. Let's do a poll. But apparently, I don't have over a fuel cut turned on. So we get all the pops. Crackles. She's a little rich. No, that's the target. Lambda's actually lean. That's weird that it's not correcting enough. Oh, the correction was maxed out at 10, that's why. Okay, and then we got Excel fuel. So I put my foot in a little bit and I tripped some Excel fuel in there. You see right there. So at the very end, I get a little squirt at the end. Um, it hit 14 psi right at the tip there, but otherwise it was 6. Some fuel pressure looks all right. Yeah, that's not departing too bad. All right, air mass. That's what I really want to see is this. So through this zone right here, we see the map air mass is higher than the throttle air mass. Throttle air mass is lower, and our um, pressure ratio 8.2, so I wasn't full open yet. Throttle effective area is 49%, so I need to add a smidge to that zone, that 49% zone. So throttle body model right here is where it was. So this one needs to go up a little bit. That makes sense because we knocked this down, and it looks like it needs to go this end of it have to go up a little bit and in like that. And that makes sense. I was knocking it down to make it blend with those other ones a little bit, but you get a little bit of this, a little bit of that. You can get with this, or you can get with, yeah, I guess we're gonna do Dominic sings the hits here in a little while. That's a quick way to lose all my followers. Okay. And then I go to engine functions. We're gonna go to our wideband. And this one, we're gonna let it add all that it wants. We're gonna go 30%. 25 is the limit. Okay. Tip there. Okay. Now that VE was climbing right here. Let's go back to the log there. Right here. The VE was really climbing. I mean, it was 4%, 4% lean. So that's not a ton, but plus 10, so 14% lean right there. Um, and the throttle was most of it. Map was 1/8. Air mass final was the middle. Okay. So most of that's the throttle. Just a smidge of that is the map. Change that 22. That changes how it behaves as it pulls into that zone. So the map is still a little high here. I could tweak cam timing and see if it's, a function of that or not. I'm not going to do it right now, but it could be. It could be a little high. Let's go 25. Let's fix this spot. Well, maybe not. Looks like it got worse. One seven. Let's do a big change. 35. Okay, that's way worse. Go back the other way. Let's go 15. Surprised by that. Let's go 20. Yeah, it looks like it wants that lower value, 15. Let's go 5. No, it doesn't want that. 10. So 10 to 15 is looking like the sweet spot right there. Yeah, it's like 15 is our spot right there. And if you think about it, that makes sense. Because under high vacuum, if I have a lot of overlap, I'm sucking exhaust into the intake port. So in high vacuum like this, I don't want to suck exhaust in the intake port. So that's our spot right there. But then when we get up here, where the intake pressure is more than the exhaust pressure, or at least equal, well, that's another story. If it's equal, I still have velocity on my side, the intake charge velocity on my side. It's not as big of an issue anymore. And then the actual increase in compression by having the cam more advanced will give us more torque. So it really does matter what the exhaust pressure is on these. Okay, so velocity plays a part, and pressure plays a part. Now you see my TMF and my map have skewed a lot at this point. I also adjust my outflow scaler, which is going to affect TMAF a little bit. It's really good right there. It's really close to that region. So right here, it's adding a bunch of fuel for 11% right there. 12%. Okay, so 11, 12% through this whole zone. And both both my map and throttle are low right here. Well, they're the same, and it's saying I need more fuel right there. So let's see. Oil pressure dropping some more. I'm at 12. I don't like that anymore. I was hoping it would just clear up a little bit. Some fuel would boil out of it or whatever. But add a little bit of heat to it. It's getting a little low, so I'm gonna look at it. How's it going, dude? Good. Yeah.
Hey, just curious. Obviously, I know we're getting a tune, but so what would you charge to retune like after? Because I am going to do lanes rotated setup. I do want to do that, but what would what does it cost to get that retuned? Obviously, so
It's hourly.
huh?
Hourly.
Not really.
Hourly.
Oh,
So
no,
it's
no. By the sounds of it, he says he's got to do some measurements.
no, no, I'm saying my fee is by the hour at that point.
Oh, I see.
Instead of being a flat
I
rate.
thought you said how early.
No, no, no,
Oh, okay.
hourly. Yeah, yeah.
Fine.
Yeah, yeah. You're good.
I totally get that. I was like, I'm sure it's going to cost something. I ain't worried about it.
Yeah.
Is that to be able to hold a tune or not?
No, no, it's gonna be I mean the VE table is gonna change some
Yeah.
because our back pressure is gonna change. but it's not like it's drastic,
Yeah,
right?
now I'm curious to see what you do with the turbo pump. It's not gonna be any better than Garrett, boys. Yeah, I'm talking about.
I know they are, but they also don't know anything, so I don't think it's gonna be that fancy. They still have weird compressors on them.
Yeah. What about you like those Joe injectors or 17?
50s?
Yeah.
Yeah, they seem to be really good. I tuned one on pump gas with a link the other day, and on pump gas it did okay even. So,
I just figured.
better than the 1700s.
Yeah. No, that's good. 'Cause I know you don't like the 1700s. That's why I won't do that.
Right.
But if those 1750s did better, you never know. But
Yeah, it's not that I don't like them. It's just that they're not made for running pump gas a lot.
yeah, 1300s for daily
Oh
driving.
yeah, absolutely. You can pump gas on 13s all the time.
Yeah. And I know, like, I would love to. So I was want to do obviously different do the head stuff on with the bigger spring, better springs and stuff, all that stuff, and then
Does it need them?
probably your camp and shit. That's what I was thinking this the springtime.
Okay.
I think we better go that route. If I'm gonna get into them, I might as well put those camps in.
Oil level is good.
What was that?
I said oil level is good on this thing. No sparkles, looks good.
Yeah.
So
Motor?
yeah, it just has low pressure. It dropped down to 10 psi at idle just now, or 12 psi. I mean, yeah. But there's no sparkles on this, and the level's fine.
You like these intakes?
No,
No.
not really. But typically they result in a laggier car. But this thing is super snappy, but it's got higher compression, which helps with that. But it is super snappy. It's got mic cams, pistons, and rods in it. And it's a 2.3.
Oh yeah.
It doesn't feel like a 2.3 though, like as far as how much response I have down low. It feels like a 2.5. And the turbo doesn't feel that big. Like it feels like a small turbo because it's so responsive down low.
Yeah.
But it's not.
Yeah. Picture.
Yeah. All right, I'm gonna leave the hood up a little bit so his oil cooler does a little more work. Oh, get the oil temp down. Yeah, it just needs to have a duct to it.
Yeah.
Otherwise, it's not doing anything.
That's fine.
So,
Fine.
oh, it'd be perfect. Yep, absolutely.
Yeah, I need to get come here.
Oh, is that yours? Oh yeah, it gets run into a lot. You know, like bumping into it and
Part of falling in. That's what I told him. I was like, because if I'm gonna I'm
yes. Oh yeah,
like,
yeah, yeah. You don't want that ripping.
Yeah.
Yeah.
I think that hood scoop that I have on the other one, so that's the ARC one.
Does it fit?
I saw our RPG make one, and I think I put one on there. So.
Yeah.
Cool. Well, I'll be talking to you soon then.
Hi, bud.
Yeah. See you Friday.
See what? Now it's 23. So, I guess oil's just getting warm. Open the hood so the oil cooler has airflow over it now. That'll help cool the oil down. And I bet that pressure stays better. Okay, that's right on. That's 3%. That's 5%. So let's do that. Okay. And we get to 10%. Then we get to 11%. Make that 13. That. And that's 12. Okay, so 13 was good. I like adding VE. That's always nice, especially when you start seeing where the engine starts to come alive, where everything starts to come together and work in unison. That's always a wonderful feeling. You get to watch the V table build as the airflow starts to just scream through the motor. I love it. All right, and I think over here, I'm gonna add some more all the way up top though, because it looks like this thing's ready to carry. Do dig it. I don't think I need to lower VE that much up there yet. I think this is gonna carry better than that. Probably not that good, but sorry, I'll start high for now. I like seeing that. Haven't gone up there. Not that I plan on being up here in this. Actually, I need to correct myself on that. As boost builds with this type of thing, this is going to start to drop down this direction. So really, up here this is high boost, high RPM on this type of fuel model. If it was just manifold pressure, it'd be up here, but it's not. We're doing exhaust pressure combined. So what happens? This will go up and it'll drop down. So um, that that VE is going to dip. Now the cool thing about this kind of fuel model is I can tune the engine at 40 psi without ever hitting 40 psi. If I wanted to take the engine and rev the crap out of it in like second gear with hardly any throttle, just run it through here and with manifold vacuum, the manifold vacuum will be the same differential pressure across the throttle body than like say 30, 40 psi of boost across the throttle body. Um, and then also across the engine because the exhaust pressure will be higher than the intake pressure. So throttle body was wrong. I meant just across the engine. So because this is map versus Z map, so I can tune this thing at high RPM and light loads, and as long as my exhaust pressure is um, uh, higher than my intake pressure, as long as I have like manifold vacuum, as I rip up here, it'll be like the exact same load on the engine as like super high boost with high exhaust pressure. Whether the boost on the engine is 100 psi or 5 psi, as long as that ratio to the exhaust is the same, the fuel model is going to be really, really close up there. And that's one thing that's really fun with this type of fuel model. Uh, oops, I did it again. I figured it out. Hit V. It's not V that I want. It's C. I accidentally hit the V button. It's right next to C, as you may know. So, all right. And pressure is now at 28 psi. So the oil temp was just get hot with no oil cooler on it. Well, it's got a oil cooler, but no airflow across the cooler. He's got it in the engine bay under the hood, and the hood was shut, and there's no vent above it. So now we're at 28 psi at idle. So that gives us an idea what's going on there. Alrighty, let's do it again. Man, I like the way this V table's looking, the way it's starting to carry up in here. Obviously, as I said, as we get a higher boost and everything, it's going to creep back down. So, I may need to be adding stuff right here. In fact, I'm going to do that just to, as I start adding load. I don't want to be like, oh, look, the wideband is working correctly. It's adjusting fuel for me. That's nice. It's nice to have that much authority and have it do its thing, and save your ass. One reason why I love the EMtron is it's really aggressive, and as long as you let it, it will save your ass in closed loop. I give it full throttle right there. See where it would go on wastegate, and it was not rich enough. Well, the correction was doing its thing. You see that the lambda did track the target, but the correction was really high, really positive. So so I stopped it right here. So this is our ignition, dropping way down, way down. That might not even be enough. I need to go look further than that, honestly. I need to pull more out of it. 'Cause we're at 17 pounds there, so yeah, I probably gotta pull some out. Okay, and then yeah, so we had 17 pounds on it. You see the air fuel ratio was close to target as the boost came in, but it was leaner than target before that. Uh, so this whole area of the map with my foot down needs some fuel. So is it air mass based on speed density or based on throttle? I mean, you see here it's based on throttle. Look at that, how low the throttle is. So the throttle air mass is much lower than that. Now, pressure ratio is 1. Okay, so that means that the amount of effective throttle area was 98%. As you see here, it's basically 100%. Okay, so how do I tell it to add more air? And that's that thing I was talking about with you before, telling you how um, we're still at 50%, but it's not accurate up there. So what do we do? Well, that's where this comes in. Uh, Air mass, throttle mass airflow, which is the page we're on right here. Click it anyways. See right here, this 22. Now with the Subarus, I typically see 18 on here. Still hit 18. And then what is it again? But we'll see. That might be too big of a jump. Oh, I'm a little timing out of it too. Let's go back to that real quick. Let me double check my Z. We're on the first timing map, which is the low timing map. Right here. I need to pull it down. So the issue is just I need to adjust this axis a smidge because this airflow is for a different displacement by just a tiny bit, 7%, and that'll help. Or I can drag the whole map down. It doesn't matter either way. Both will work. I'm gonna start by dragging it down. We're gonna go through here, go down. Some 1 degree per click. So I just pulled 3 degrees out of it. But I don't need it to be linear in that mid-range there. So what I'm going to do is pull this down a smidge too. I want to fix some stuff here. I'm doing this big change to get this one spot down here low. And get this guy here just for starters. So then grab this bitch. That real quick. Oh, see, that's way too much. Not enough. There we go. Like that. Grab this guy. Knock down a few right there. Just some big adjustments right now. Big sweeping adjustments to the pump gas side. Never hit this zone right here. This doesn't exist, right? Like, never going to be 1.6 grams at 1800 RPM. That just ain't happening. But make it look nice. Okay. What was oil temp? I don't know. He's got a sensor, but it's not on the screen right now. But it's happier now, so it's fine. 9/4? Oh, there's a selector on the thing. That's one thing about these shifters that I don't like is that you can't freaking tell what gear you're in because like everything's so close. So The gear selector on the screen is right there. I should probably look at that. All right, well, I like that. This got closer. You can see here the throttle got closer to the map, but it's still not quite there. But it's much closer than it was, so that's good. That's a good start. And if we look at our air fuel ratio, it was really close. Look at that. Look at that correction. 1%, 1%, 3%, 3%. Right here, it's 10% as the boost is building. So this zone right here, it's 10% off. But through the power up there, we nailed it. Up top there, greater than 5,000, we nailed it. That's excellent. But right here, not so much. So 9%. So we're gonna go to air mass. Take a look at that really quick. Throttle is lower than map, so that needs a small tweak. Oh, that's surprising how much I have to adjust that. That's where that outflow scalar um, correction comes in, where you can tweak the outflow to make it closer. Because right here, it's right on. Look at that. Throttle effective area, 98%. That's right on. It deviates right here as pressure increases. As pressure's increasing, we're losing some reading. And they're both increasing together, right? The outflow, like I said, the pressure ratio is 1 to 1. Boost pressure and manifold pressure are within 1.4 kPa, which is minuscule amount. So you can do outflow to get that, but like I said, right here it's perfect. And pressure ratio here is 1. So if I do outflow adjustment, then that hurts me here. If I just change the overall outflow scalar, then that hurts me there, right? So right here, this guy, if I scale that, then I lose that zone. Then this will go up and get tight, and then this will be off. And you're like, well, some bitch. So let's look at the fuel here and see how far off that is. Maybe that's actually the right call. Let's see. 0. Now the correction's really low right there. So no, that's not what we want. Right here, as it starts to build, that correction goes away. So we can tweak that, like I said, based on the uh, the outflow scalar compensation, which is in the tuning table TMF measured correction table, that one, and we can populate this table and then adjust it. Um, it could be the filter. Could it be the filter? No, I guess not. Oh, maybe. It's possible. I don't know if the filter does it just if it's a filter and change in value overall, or if it's only a change in value during throttle change. That I don't know. That would be something that'd be worth knowing. Um, if it's oh, and this, like I can add a smidge to this, right? Get it closer. Put this at 99. That's 1% more, right? That's a teeny bit more air. Make this one 98, like so. And this guy a little higher. That might add a little bit of fuel to it. But I do need to know if that filter affects it on changes in the calculation or changes in throttle only. Because if it's in calculation, then yeah, this filter can be too stiff. If this filter is too stiff, then um, this EMtron default, if it's too stiff, then that would be the thing. Hold on a second. I got a bunch of text messages that came in. I didn't see. I'd love to get more info. Same. Okay. TCCD might be unplugged. Oh, that was Nolan. Okay, that was a car. Dewey laughed at my text message, and my brother-in-law is being a dork as always. Okay. Had to get behind the glove box. DCD is unplugged. All right, so we're gonna take this filter and table, turn it off to custom table. Custom table, and then I'm gonna go to the filter and see what pops up. See how it populates. Okay, like that. So in that zone, there's no filter. So it ain't that. Question answered. Yeah. In that zone, there's no filter going on, so that ain't gonna be the problem. That's not gonna be it. So we're gonna hit default, and so we'll go to the other table. This. Um, how do I want to set this table up? Now, that's a good question. Will I hit that spot where it's off at that exact RPM and load? Or is it only while it's changing in that zone, right? So if I stop it steady state in that zone, if I was able to somehow snapshot that and it sat steady state in that same zone, would it still be off? Or is it the change of load that's doing it? Is it as the RPM climbs that's making it lag behind? You know, what is causing it to happen? Now, I don't know the answer to that, but that's where your mind kind of has to go to, ouch, to troubleshoot, things like this. So this is outflow correction, so it's only there when we're on the outflow mode anyway, so I don't need to worry about throttle pressure ratio because it's already there. That's already covered. So the question is then, is it just engine speed? Will it be just engine speed or will it be also based on pressure? I don't know the answer to that. But because I don't know the answer to that, I'm going to set it up as engine. I'm going to set it up anyways as this. We're going to go 50 kPa with 25, I think. Oh, it's just, I only got 5 cells in this direction. Okay, well, 50 makes no sense because I won't be in vacuum in that spot. So here we go. That looks good. 250 works. Okay, so now we're in that zone. All right. And 250 manifold pressure. I might need to start even sooner than that. So, let's make this 175. That. Sure. Do that. Now in that zone, I got that. And we'll go. I keep saying that a lot. That's not very helpful for you. I apologize. So we need to add 10% to this whole section. So from here, we go at the very beginning of the 10% chain. Okay, right here. Where is it? Right here. 10% right there. I'm low on that table now. That's fine. I go 10%. Okay, and we'll go log. And then we're going to go, okay, it drops down 10% right there. Where's that at? Right there. Okay, do this like so. And then this is going to be 5. And then we're going to go like this. Fill that in. And then we're going to see where it drops down. See here. Oh, shoot. That's not right. That's not right. I'm sorry. I did that wrong. I look at this one. How far is this off? Not the total airfield, because that's the calculator. I need to see how far is the throttle off of the map one, which is much closer. So, but looks like it's about 10% because the throttle is 8, the map is 9, and the air mass here. So, yeah, looks like that'll work. I'm just going to hit 10% from here on up. I'm just going to do this just so I can log it, and see what we get. Now, I'm looking at this and I'm thinking, this probably isn't the right way to do this. I should probably set the outflow scaler at the top end and then use this table to tweak the bottom midsection. Honestly, as I look at this, I think that maybe this isn't the right avenue. I don't think it's incorrect, but it might not be right. It might not be like the best way of doing it. It might be better to set the outflow so the whole top end is set and then use this table, shrink those values, and do it for just that mid-range section. So I don't. Okay. That's a lot closer. For here, a little bit off there still, top, the very top end. Um, Looks like it went a smidge high right there. Right here, it's a smidge low. So I can actually change that outflow scalar a smidge, reduce this a little bit. This will pop up, that'll come down, and that'll pop up, and that'll be closer. See what our total corrections are. So now we're rich through here by just a tiny, tiny bit. Oh yeah, that's really good. Oopsie. 8 degrees of timing here. I got a little correction right there. I got a big spot right there. 11% in this zone. So we pulled some of it out, but it's still off right there. Looks like I got a little. Oh, that's the cursor. That's funny. All right, tuning. Let's go back to that table. 10% still in that zone. Let's go to air mass. Let's zoom in on that a little tighter. See where air actually is between the two of them. So I'm going to zoom in by dragging these bars so we can see how big is that error. Yeah, it's there. It's there. But it looks like the whole thing needs to come up. Map as well. Because it's still 10% off. So it looks like it all needs to come up. So let's go to our VE table and look at it. See where we're at there. I don't see it. What's going on here? Double click it again. Go to tuning. Oh, it was so camouflaged. I didn't see it. All right. So yeah, I could see adding a little more right there. I can see that. Okay, how about this zone? Where's that at? Let's go down here. Still adding 8% right there. Okay. 90%, which I can see that. Look at that, because it kind of dives down right there. Alrighty. Let's add a smidge more right there. I need to increase the resolution of the table right there in that spot. I might need a little bit of work right there. Okay, let's go to the top end real quick. See how that VE table shifted on us. Hit W, unzoom. Go here. Got the 6600-ish. Okay, our boost is right at, looks like 21. It's got 21-pound spring? No. Hmm. Target boost is there. My initial is at 0, though. That's interesting. Yeah, there's no wastegate duty cycle on this. See, it's 0. Not even on here. Oh, wait. That table moved. It's over here. Oh, it went to 17%. Okay, so it did try to get boost a little bit. Boy, it sure laid on the target. Look at that. Okay, I'll take it. All right, anyways, let's look at exhaust pressure. 263. Wow, so it's just crossing right here at 58 at this boost level. Exhaust pressure's even with intake pressure, almost like just tracking it. And then it goes a smidge higher right at the top end. I think I'm actually letting off right there too with my foot. So that's not much back pressure right now at this level. Turbo speed's only 70 something thousand. I do need to double check that I got the scale right on that because that seems low. It might be right, but that seems low. I should check the scale on that turbo speed sensor. But that back pressure is nothing. That's nice. It's really good. Which means on our VE table, since that back pressure isn't very high, that VE table is not going to be diving down very far yet. But you see, it came down some. Look right here. See, it's coming down this direction through here. And that's what I was saying, that as it comes in, it starts to fall off. Oopsie, I want my palm striked it. So you see it'll start to fall off this way. As we crank boost up, it's going to start going down through here, which makes sense because the VE on engine goes down when you start putting a lot of exhaust in there. If you think about that, if I have, say, 40 pounds, 40 psi of exhaust back pressure, or drive pressure as the diesel guys call it, or EMAP as this ECU is, that exhaust manifold absolute pressure. If I got 40 psi relative in there, um, when that exhaust valve shuts, the volume in that cylinder that's residual has exhaust gas in it. And that volume is going to be 40 plus psi because the piston moving up, it has to have a difference pressure across the valve to get the exhaust out, and high speed is not a lot of time to get it all out. So chances are it's going to be 50 psi in that cylinder versus the exhaust, okay? So it's going to have a lot of pressure in it. And when the piston moves back down, it's going to be a while before that pressure drops enough to let fresh charge in. Because the boost is only, we'll say, 20 or 30, right? So it's going to take a while for that pressure to drop enough for fresh charge to start making its way in. Now, what's really neat about that is when the charge first starts hitting, when it actually starts flowing, that exhaust is going to rapidly cool, and that fuel is going to vaporize. So you're going to get like a wiggle in the pressure in the cylinder at that time because it's going to be dropping, dropping, dropping. It's going to dip really hard for a second. It's going to drop slowly and then go as the cool air hits it, and it's going to drop a bunch, and then it's going to kind of stabilize. And the piston's going to moving down, and that cylinder is going to start pressurizing with the boost. But you can see a little wiggle as that fuel and air start hitting it and sucking the heat out of that residual exhaust and mixing and combining and everything. So that piston had to move down before I started getting fresh charge again. The further that piston is down before air starts going in, the lower my VE, my volumetric efficiency, how much volume I am using out of that 2.3 liters, right, is going to go down because a bunch of it is occupied by exhaust gas. And that's one reason why when I see a VE-based engine management system claiming 130% VE on a turbocharged car at 30 psi, I know that their fuel model is shit because that's not fucking possible. That ain't happening. Now, maybe 120, 130 PS percent when you have, say, 14 pounds of boost on the manifold with a huge turbo and the exhaust pressure still really low. I can see that. That's possible. But on the top end, the VE should be dropping like a rock. And it should be less than 100 on a lot of cars. It should be less than 100 when you get in. As soon as that pressure crosses over, as soon as you hit this point, it should be less than 100. Maybe you get a little leeway with inertia, but for the most part, it's going to be less than 100. Where are we at right here? 106, but 101 right just below it, right here in the spot. And I don't even know how close I am right now on the tune right there. So we can see it's already coming down. Let's go a little higher. I mean, they're on each other pretty much. Here, we'll move it even to here. It's a little higher. We're dropping down 101, 105. So I got a little bit of inertia on my side and some error and a few other things, going on with that. Plus, what's our fuel correction? We're richer than target, okay, and it's pulling some fuel. So we're richer than target tells me that my VE map is too high anyways. And that is on the map side of it. So, okay, that makes sense because we're richer than target. This looks unrealistic, and sure enough, it's pulling fuel. So it is unrealistic. So if I pull a couple percent out of that, then the next pull, that thing should be a lot closer. And sure enough, look, a couple percent out of that becomes 101, becomes 100. Here's 99. And so what we're going to see is that the VE does in fact drop less than 100, and it should. That's what it should do. That is 100% the logical result of having higher back pressure on an engine than you have boost pressure. And by the way, 32 psi at idle right now. So that oil was hot. And honestly, I'm glad it got hot because I wanted to get fuel that was in it boiled out of it and all of that because this car had a bunch of starts and stops, starts and stops. I did a lot of them. Getting the startup better, getting gauges to work, fighting with that for a while, trying to figure. I had to fix some wiring today. One of the connections was not connecting well, and the car would just spontaneously start going and start flipping out, and the connection was bad. That's an issue with old '05 terminals. Even though it may not be cycled a lot, it's been sitting there in a position that's compressed. That metal has been compressed because it's got a pin in it, right? And so the terminal's got pressure on it that's trying to open it up, right? And it's trying to clamp down. And you get heat cycles, and eventually that clamping force drops. And so that's what happened. I put a different plug in it, and it was connecting-ish. And if I would jiggled it, it would drop out. And so what's happening is the map sensor was shutting off and turning on and shutting off and turning on. So I rewired it, and now it's good. But this thing had a lot of starts and stops, so I want to get that oil hot, get the fuel out of it. Feel a little hiccup right there, a little burble. Might be cams, might be something, I don't know. Okay, so right here, you see the map went above the throttle. Okay. I was just seeing what would happen with that light load. All right, let's do it again. But I'm gonna give it more throttle this time. So I didn't change that outflow scaler, which I wanted to do. Well, this thing feels like it wants to take off. I haven't got to ethanol yet. All right, so I'm gonna bump that outflow scalar a smidge here and here. Bring that down to 17. Now, these things are interesting. This, as you get closer to the target, the change becomes bigger. Um, so 17 might be too much. 17.3 might be the answer. So we'll see. But as you get closer to that target, it starts to swing quicker and quicker. Um, you'll make big changes and you just stay far from the target. And then all of a sudden it goes through it. And I'm also going to go here, go to this guy. I'm going to go to 0. 0. You know what? Let's go 5 across the board. And I'll tweak it later. I'm going to change the RPM range though. I'm going to go down in the RPM. So I'm going to say 2000 and then 500. That, like that. So we're going to be now kicking that zone a little bit at the lower loads. And I'm going to take this guy. I'm going to make this 100. And we'll do 25 again. And we'll generate that. And we'll hit sure, it doesn't matter. There we go. Now we're going to tweak that load down below. I'm going to work on getting that upper section correct and then use this to tweak that small section. That's more logical to me. That's more logical of the path. Oh, what's that? 2026 nail check. First of the year, huh? Manicured! No, I'm not really manicured. But I do have a freaking blood blister in that one. Look at that. Oops. Finger goes smash. Some of my wiring just crunchy. End up having to do a lot of, yes. Yeah, so you get it. Yeah, old stuff will do that. Oh, that power curve's not showing, is it? Oh, because I have the air fuel on here, which I'm not using this one. I'm using the log, so let's do this. Ooh, the power curve goes up. Power curve makes angles. What did I say? 500. Okay. Let's go to the last one, see what you did. Bing, bing, bong. Look at that. Zoom. That's why I said it feels like it wants to go. That's pretty cool. I like it. I'm a fan of that. What time is it? Fuck, it's almost 5. I didn't get a chance to get ethanol done today. I have to come in on Saturday or Sunday. Oh, that beautiful flat torque curve. I love it. Ah, I like that. Get some timing cuts. Figured that would be. You see here, my noise level is too close to my threshold. See how close that is? So little wiggles bring me over the threshold. I mean, that's very uniform, really, especially for that RPM. So the threshold needs to go up. This engine's a little loud. Here, a little bit of piston slap. You know, it's got some a little bit of little valve train noise. Um, it's louder in the car than it is in the engine bay, but yeah. So yeah, so we've got some timing being pulled. 6 degrees right there. Just responded to this little spike right there. Yeah, I got my threshold way too close. Way too close to the background noise. Now I can either raise the threshold or lower the mic sensitivity, but either one will do. Ideally, I'll be honest with you guys. Everyone tunes pump gas first. I kind of rather tune ethanol first. Right? I'd rather do like the low boost tune on ethanol first, so I can get like the engine noise profile really narrowed down to where I know that That is the noise the engine makes when it's not knocking. Honestly, I kind of like that. Instead, here, I have to analyze the curve, look at the sensitivities, look at the graphs, see if it makes sense to go, you know what, that's just a loud engine right there in that spot. I don't think that's knock, and all of that. Whereas if I did it with ethanol, with low timing and low boost, and just got the engine profile, I know there's no way it's knocking right here, then I could use those numbers as the baseline and go in. But this timing pull, this is a lot of time pull, like 8 degrees on cylinder one right there, and 6 or more on cylinder three. So 1 and 3 are indicating louder, and that's just look at that side of the engine the whole time. Even in this zone, 1 and 3 are louder. So that's probably the gain. I probably got the gain set down on 2 and 4 too far. Um, yeah, I kind of part of me wants to just say fuck it and put ethanol in it now, and then come back and finish pump afterwards. Oh no, I still have 1 and 3. Well, they're less than 2 and 4, yes, but I raised 2 and 4 to come closer to 1 and 3, and 1 and 3 are still the loud ones earlier. Huh. Just double check, make sure I'm reading that right. 3 and 1. Yeah, sure enough. That is exactly what I'm seeing. That is bizarre. I gotta think about that for a minute. I had to go that far. This is, like I said, it's a base map for another Subaru, just like this one. And they both have the same trend, where 2 and 4 are quieter than 1 and 3, which doesn't make sense because the knock sensor is closer to 4, and in every other car I do, every other ECU I do, 4 is louder and 2 is louder than 3. Well, 4 and 3 are usually fighting for the loudest. I'm sorry, 2 and 3 are fighting for the second loudest, and 4 is always the loudest. Um, so why is this an EMtron thing? I don't know. I don't know. Oh, frequency. I bet that's what it is. Let's see my frequency set at. Go to functions, go to knock. I should have like between 11 or 13,000 hertz in there. What do you got it set at? Yeah, 12. 11 to 13, 12. Okay. Gain is 2. I usually run a gain at 1 or 2. So I can drop the gain to 1. The Subaru knock sensors make a lot of noise. And that'll give me room into my threshold that I should have there. That'll pop this noise down a smidge and give me a decent margin for that threshold. I forgot that I turned that to 2 earlier. Totally forgot. By earlier, I mean when I installed the ECU. All right. So my wires are crunching. Yeah, well, I got a blister after messing around with my suspension. Oh, yeah. Yeah, I don't remember what I smashed this one on, honestly. It's a while ago. Or this one. Yeah, I remember what hand it was. Yeah, that one. Right hand. Left hand, the correct one. All right. So that's all fine and dandy. I like that. Oh, knock, threshold gain. Okay. And cylinder gain. Okay. So the threshold gain is altered, and here's my cylinder gain, and I have 4 turned down, and 4 is pretty quiet. So really, I could bring 4 back up some. 4 and 2 can come up on my cylinder gain. Try that. Better. Okay. Go to my log again. Go back to my fueling. I made a change to the thing we haven't. Oh, look at that. That actually came out really good. Haven't reviewed it yet, but okay. Well, 17 worked. 17 worked and 5%. Came really damn close. That looks really good. And here it's closer. Here it's off, like I said it would. Oh no, that's actually not outflow. That's outside the outflow. This is outflow here. So that looks good. Honestly, that looks really good. This could use a tweak, but I'm not sweating that right yet. All right, let me show you guys this keypad while you're still here. If anybody's still here, check this out. Okay, this is the EMtron keypad. Now I love this thing. This thing is awesome. What I love about it is you can have a button be 4 position, I should say, I'm sorry, off, green, I think it's yellow and red, right? Orange and red, okay? So 4 position, that's an option. Or you can have it be, which one is it? You can have it on and off. See here, just on and off. You can have it be um, momentary, like just when you're pressing it, okay? Where'd my 8-bit one go? Oh, it's not there. Okay, I gotta change that now. So let's go to config, communication, EMtron, CAN devices, keypad. Sequential for toggle 2. So let's change this one to binary 8. Check this out. So the top right, okay, now the two together. Okay, so now this thing has got 8 positions. This one switch now is an 8-position switch. That's fucking cool. So I got momentary, just my finger pressing. I got 2 position. I think is this one here. Yep. I got 4 position, and I got 8 position on this keypad. That is so slick. Um, yeah. Anyways, I wanted to share that with you guys. Super fucking cool. I hope no one likes it. And send me that thing, dude. I want to put that in with the button controller in here. I want to get that. I want to get that in here. Now, I have no idea what I use 8 positions for. I suppose I can use 8 positions for a boost trim. Can do that. But there's an 8 fuel models, so I won't be doing that. And there's not 8 cow slots for other stuff. So if you know what a cow slot is, I'll show you guys here real quick. So this has got cow slot control. So here it's set up for Anvil 1, which is normally like SI drive on some stuff. Um, I don't know what these are identified as. Nothing yet. So we're going to change this to, let's see, let's say keypad button 1. Okay, keypad button 1. That's going to dictate what drive mode we're in. And we hit OK. All right, so now we got this. So now I'm going to hit the button. There you go. See the white block right there? 1, 2, 3, 4. Well, 0, 1, 2, 3. Those are the 4 positions. Okay. So now this is going to be the top left button, and this is going to change maps. Now, what maps does it change? That's what I want to know, right? Well, that's not. I already know the answer. You know, it's right here. So then we go to count slot control. Now, slot 1, slot 2, slot 3, slot 4. Oh, I don't know if that pops up on your screen. Let me check. No, you don't see it. 8 positions. Yeah, 8 maps, right? No, but we can't do that. Let me see if I can get this on here. Okay. To get this on the stream, we're going to have to do this one. Yes, that's the one. All right. This should read now. So you see function, cow slot 1, cow slot 2, 3, and 4. So right here is 1, This one could be 2. This will be 3, and this will be 4. So now I can have 4 combinations, and in these combinations, I can change the V table if I want, which one I want to use here. Table 1, Table 2, main ignition tables, launch control tables, traction control tables, boost targets, speed limit, or whatever. I can set all those up. And what's cool about that is you can have yourself a high boost, low boost table map, but also still have flex fuel. So you can have trims to your fuel tables, or sorry, you can have trims to your boost tables when your boost table is already trimmed by flex fuel. So I can take my boost target based on flex percentage, change it, but then add a trim where I can go up and down, but also have a whole different map target. So I can have, I think, 3 different boost tables, have them all trimmed by ethanol, and then add a user adjustable trim to it. We're not going to do that because that's way too many fucking trims for boost control. But the point is that you can. You can do it, and that's really cool. Also, driver demand torque. If we get heavy in the fuel model, which we're not getting heavy in doing this one, but we're going to do some stuff with driver demand torque for sure at some point. Then with driver demand torque, we'll have the ability to have it just target less torque. And then the ECU will automatically adjust throttle and ignition and things like that to manage the engine torque as it is. So map limit. I set my map limits based on target boost because fuck having, we'll say 4 boost tables plus trims and then having to have a overboost limit table for each one of those as well. Doesn't make sense. So I only need 1 map limit table unless I'm trying to intentionally put like a valet mode on it or something. But 1 map limit table, and that 1 map limit table is based on target boost. When you exceed target boost by a certain amount, the map limit kicks on. That's what that's how I set it up because there's no point in having all these tables to me. This doesn't I don't get it. Speed limit, ground speed limit. That's for pit lane control, right? That's pit lane stuff. So you hit a button, pit lane speed control. You keep your throttle, at a higher percentage than it takes to do that speed, and you're fine, and it'll cut power. Overrun boost. This is for like anti-lag kind of stuff. This car is not set up for that. It doesn't have fresh air and stuff, but if it did, this is what you would run. Lambda targets. We don't need that because our lambda targets are going to be based on our fuel and other stuff, so that won't be a thing. Cam angle target. We're not going to need to change cam angles because we're not doing different angles for the user. It doesn't make any sense. That doesn't affect anything he's doing, with the exception of if I put a rolling, not rolling, if I put like a stupid excessive burble tune, I might want to change cam timing in that position. If I'm going to do like a really aggressive rotational idle just to be like a fuckboy, then I might change cam position for that, and have, fuckboy tune, right, cow slot 4, with different cam angle for it. And then dwell, definitely not going to have that. We're not doing that. We're not doing methanol and other shit where we need to have special dwell things. So 36 psi oil pressure right now, so it's definitely gone up as the oil temp dropped. Yeah. Anyways, so that's what the cal slot control is. However, that's not all you can do with the keypad because each of these functions has the ability to be trimmed. Almost all these functions. So we'll say, let's do boost control again, right? Boost control compensation tables, user comp 1 and 2. Okay, well, here's one based on barrel pressure. Well, that's a good idea because if you're in a weird area, there you go. Here's another one. User comp table 2. This is ethanol content and speed. So what I did with this one, are these solenoid comps? Oh, okay. Um, this is the solenoid compensation. So all that's saying here is since ethanol lights these turbos off quicker, which they do, I have this set up so that if you're on high ethanol, it drops 5% out of the duty table in this lower RPM region because if you don't, you'll get spikes. And that should help with spikes. So I'm sorry, target offset tables are here. There we go. Target offset, that's nothing there. This one's based on voltage. This was off of a car that had a variable voltage. And that's not the case on this, but let's say we wanted to set this based on keypad button 4. right? Which is the 8 position button. And 1, 2, 3, 4, 5, 6, 7 value. We gotta change that. Starting value is 0. Oh, that didn't work. 0. Increment is 1. And we're gonna do a total of 8. And then we'll generate that. Hit OK. And we hit no, just have it do this. And now this thing is position 0 is low boost. Position 1 is a little higher, 2's higher, 3's higher, 4 is where the map is set at, 5, 6, and 7 are above the map. You see it cycle through here, the 8 positions. Right there. Boop, 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 boop. So now I have a boost trim on an 8 position switch. And then if I want to get even fancier, what I could do is I could take this axis and hit this Y, enable this, and then put this one on cal slot, put this on the calibration slot. So 0, 1, there's 4 slots total. We do that. Oh, but they do it 1 through 4. That's right. So I forget. Clear 1 to 4. Hit that. No. Now I can change my trims to say if I'm on fuckboy mode, I only want to have an increase in boost pressure. This sucker, all those positions are only for more boost. And the more aggressive it is, the more that boost add is. So now if I'm in cal slot 4, which I go here, 1, 2, 3, 4, there, and then I want to crank the boost up, then I go over here, and I know now that all reds on this screen here, I got red here and reds here, is the highest boost setting that this thing will have, uh, plus ethanol if you wanted to. So let me turn these off. These don't mean anything. There we go. So here's our cow slot. Working through our cow slot. I don't know why one's not coming up. Oh, it's weird. This is 0, but that says cow slot 2. Maybe I tweaked on the cow slot control. Let's go back to that real quick. No, it's 1. That's 2. That's 3. That's 4. Oh. Oh no, I'm wrong. 2, 3, 4. 1. Okay, maybe it is doing cow slot 0. I didn't think they would. No, see, they don't. Okay, something's going on. Yeah, so there's no cow slot 0. It is 1, 2, 3, 4. Okay. And then we go back to boost. Boost target offset. Table 1. Cow slot. Yeah. This should be 2, and it says 3. This should be 3, and it says 4. Huh. That is a bug. That is absolutely a bug. Interesting. I'm going to pull up this. I'm going to look at cow slot in here. Cow slot 2, 3, 4. Yeah, just 2, 3, 4 is all it's doing. It's not doing 1. That sure looks like 1. 2, 3, 4, 4 twice. Oh, weird. I have 2 2s and 2 4s. Oh no, 1 2 and 2 4s. Weird. Okay, well, we found a bug. I'll have to contact EMtron about that because that is definitely not right. I'm gonna send this video to. Actually, I'm gonna take a video of my phone real quick. Where'd it go? I dropped it. Here it is. Video. Nick, I want to show you the cow slots aren't lining up. This one says cow slot 3. That one says cow slot 2. If I hit this button here for the EMtron keypad, you see here it says 3 on one and 4 on the other. That says 4 and 4. So I have no 1. When it goes to 1, that's not working. Then it goes to 2, and it says 3. Goes to 3 and it says 4. It goes to 4, it still says 4. So I don't know what's going on with that. That is weird. I'll send you this video and the calibration to look at it. Yeah, trippy. All right, well, that is what it is. I have to get them to fix that because that's scary. Because I want this to be on 1 right now, for example. Like I'm working on 1. I shouldn't need 2 to be. Not brand new. My old firm right now, it's brand new. If on latest, try to arrange it with y-axis, not x. See, okay. Does that let me do it? Let's try that. Try button 1. I wonder if the keypad button position is supposed to be 1 through 4. No, because it's definitely going to 0. Okay. Try to turn that other axis off. Take that one off. Hit that. Okay. 1, 2, 3, 4. Okay, let's see. Let's check the button. Let's see. Okay, that's tracking there. The track on the log. 3. Oh, stays on 2. No. Oh, worse. Let me try this. Let's do both axes. Hit OK. Close that. So 0, 0 is 1. 1 and 1 is 2. Yep. 2 and 2 is 3. 3 and 3 is 4. Okay, so that's fine. Now let's hit the button and go here. 3, 4. Nope, same thing. Interesting. Let me double check my firmware. Pretty sure this is the newest firmware. La, 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 la. This 122953. Okay. I'm gonna tell you this. Streaming has fucked me up because I find myself narrating my life as if I'm. No, that's the newest one. Narrating my life as if I'm streaming sometimes. I'm like, okay, now I'm gonna do this. And I'm like, hope nobody heard me. All right. Well, they got to fix that apparently. So in the meantime, we'll work around it. Oh, no problem. Yes, I'm back. Exciting. It does the energy come through your process? Um, no, not always. I would say no. Um, it might keep me more focused. I suppose that's a possibility. Let's see. Let's do this is all ones, and then this is all fours. This. I'll see this is threes, and this is twos, like that. Okay, and we'll see what happens now. Go to three. Still in two, two, four, fours. Okay, so now I'm jumping. All right, so there's an interpolation issue in here, is what it is, for sure. Because now I only get two and four, so it's not sitting dead nuts on these cells. I wonder if I can establish it as a voltage. Where's my CAN inputs at? What's this? GDI8. What is that? GDI8? EMtron doesn't have a GDI controller. Do they? Hmm? Can't possibly be something that I've been giving them a hard time about for a long time. Oh, off. So it calls it off. And then one, two, three. Oh, that makes sense. Zero's off, sure. But there's no voltage associated with that. I wonder if I can make a voltage associated. If I can, what could I do? What could I do? Okay, make a user function. Make a user function based on the position of this, and that user function sets an output on a table that then the thingy can use. Let's try that really quick, and then I gotta go home. So user function, we're gonna go. Oh, maybe I can do an input. Uh, can I do a user input? That might be fun. User input, user switch. That's just on and off. Pressure, temp. No, can't do that. Okay. So we'll go functions output user functions. We'll do 15 because it's the bottom here for SMGs. We're going to say on with no output, and then we're going to call this um, cal slot determination. Okay, and we hit OK. Boop. Why does that not have an option of it? Switches and tables. Weird. Okay, and then we go to tuning, user, 15, setup. Oh, this isn't working. It's not letting me do a table on 15. Okay, I'll change this. Configuration. Let's see. This one lets me select a table. This one does not. Oh, interesting. Okay, 3. This lets me select a table. Okay. We're gonna go duty. It doesn't matter the frequency. We're just gonna duty like that. So channel 3. We're gonna go cow slot. Hit OK. Then we'll go tuning, user functions, user 3, cow slot. These are the conditions. I don't need any of these. Channel 1. Engine speed greater than 500. Sure. On delay. On delay! None. Like that. And then we'll go to 3 again. We do our table. And then we'll set the axis to be our keypad, button 1. And then we'll clear and generate like that. And then we'll say 0, 25, 50, and 100% like that. And then we'll go cal control and we'll set this guy to user output 3 like that. And then we'll have 0, 25. What? Oh, it's not status. It needs to be duty. I'm like, oh, that's a bullshit. User 3. User 3. Duty cycle. There we go. Like that. And then we do this. We go 25. That didn't work because these are in the way. Delete. Delete. 50. And 75. What did I do? What did I do? 25, 50, 7,500? What did I do? I forgot now. Now I forgot. I got distracted. Yeah. What? No. Oh, it's fine. Leave me alone. User functions. What did I do? 25, 50, 100. Okay. I didn't do a 75. Whoops. Now what I might need to do is add double the slots and have high and lows in there so that it can drop in between them. Okay, 1, 2, 3, 4. Okay, that's tracking. See there? Like that. Does this work? Search. Cal. Cal slot. Cal slot 1. Cal slot 2. Cal slot 3. Cal slot 4. Bam! Workaround. All right. That's exactly what I did. That's funny. He texted me while I was doing that and said, make it a user duty. All right. Cool. Now they work. Bing, 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 bing. Let's go back to 1. There we go. All right. 4. All right. It's 5:30. I gotta call it quits because I know the guys are gonna want to leave. It's a Friday and all of that. They come in probably like Sunday or Monday or something and keep going. But oh, I should probably do warm pull. Check my login real quick. With those changes I made to the knock control and all that, I should do warm pull. This thing runs good. I'm very happy with it. Okay, it's pulling 3% fuel through that region. Is adding 4% right there in that spot. Okay, I'm all about that. Timing is 7 degrees right here at peak boost at 48 with 14 up top. So there's no freaking timing in it. And we're rich. We're at 7.2 lambda. So I got this sucker rich as balls on pump. And overall, it looks pretty fucking good. Let's look at our air mass. Still has some difference in there. You see the throttle now is on the high side. It was on low side before. Now it's on the high side. So that means our map air mass might need to go up a smidge. We did drop it down some earlier. Remember, we dropped it down a little bit there. So we should check that really quick. Let's look at that real fast. Fuel. Uh, um, right. Oh, that's not fuel. Dummy. Right there. Just under 100, like we'd expect, like I said before. So that's cool. That's looking good. Let's go to our login, go to boost. See what we got. Exhaust pressure starting to rise up there. Look at that. See that? So I pulled it to a higher RPM than I did before. That's coming up. Looks really good. Really happy with that. See to add to the map a smidge right there. Oh, maybe was that? It's pulling 3%, so maybe not. Maybe I need to just drop that outflow a tiny bit, and that'll bring it all right in. Last thing, cams. Look at cams. That's the duty cycle. Don't freak out. That's the duty cycle. Here's the cam position. Look at that. Track and target really well. That's tracking target really, really well. So that's fucking good news. Uh, Throttle is wide open. I love that. Power curve looks like the dyno. I'm assuming. I didn't look at the dyno yet. How's it look? Oh, look at that. That's about right. Look at that sucker. Wavy. I'm loving that. Holy shitballs. Look at that shit. I like that. Okay. That wiggle, I believe, is from the really low timing right now, if I had to guess, 'cause the timing's so low. There is a little bit of wiggle in the car too, and some of it could be the diff control, actually. Let's double check. That could be diff control, since it's not plugged in and it's trying to control it itself. So when I find the DCCD, see if it's plugged back in, see if all that stuff works. But look at that power curve. Holy crap. That's a good time. This shows I pulled the 7300. EMtron says what? 74. Okay, good. So my wheel speed on that is really close. That's really good. Yeah, this is all really good. Really happy with it. And this turbo speed, it shows about 75,000. I think that's low. So I need to double check the blade count on the 825 and then do the calculator, get that in so we can see what turbo speed really is. I have a feeling this should probably, right now, this power level, be like 98 or something. I feel like we should be more up in that range, somewhere there possibly. So we'll have to figure that out later, not right now. But for now, you guys got to see cam timing making a big difference in torque power output and well, no, in just VE. You didn't see the actual power output, but in VE you got to see that. You got to see um, the buttons. Obviously, we showed that and how to work around that axis issue, whatever. But it's good now, so that's really cool. You got to see me do TMAF. You got to see how it blends with a pressure ratio based volumetric efficiency curve, which is what we're using here. And again, like I said before, we're not going to be in here. Like this isn't really, we're going to pop up here a smidge and then drop back down. This is all in case something weird goes on, but you know, we don't need it. The the whole map is going to be like this. We're going to be right through here, this whole zone. And this zone is the same as a lot of other areas. It's really cool. Let me do the little blend right here. Uh, so it shrinks your VE table, which is fine because we're not only using the VE table, right? We're using the VE table and the TMAF. And then a little later, I'm going to set up TPS-based fueling as a backup. So he'll be hitting one of these buttons here, and it'll switch over to TPS mode. So if he has an issue with, like, say, the wiring on the sensor goes out and we lose his boost pipe sensor, he can hit the button, put it into different mode, and then that'll swap them over to the into a TPS based fueling, which is like TMAF, only it won't even use the charge pipe sensor either. It's only based on mat pressure and the throttle position. And honestly, I might even throw in some estimated stuff in there as well too to see if we can get it to be uh, as reliant on as few sensors as possible. And um, then we have to set up motorsports things. We'll have to add some more shit to this keypad here, bloop, 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 and make motorsports things happen. So overall, I still got a bunch of time on my hands ahead of me, but as you see, the pump gas fuel map was actually pretty quick, right? Getting that together was actually pretty quick. Granted, I've been doing this for a long time, today, but that was troubleshooting other stuff, doing other things. I had to set some wiring, fix some wiring, check the oil, get the thing going, right? A lot of other things are going on. So I use a lot of time in that. But setting a fuel map isn't that bad, and the T map makes it pretty quick because it kind of gives you a quick, adjustable, scalable thing, and then you can maneuver everything else around it. But building a VE table is about the same time, and then the T map is quick. So um, overall, that's pretty cool. And I think that's about it. I don't know what else to tell you guys about it, but if you have any questions, obviously you know where you can go, the website, my Discord, and all that shit. So that's cool. Yeah, this is pump gas. This is pump fuel. So I no need to push it very hard. This is wastegate pressure. Oh, actually, no, it's got 16% wastegate duty, right? So yeah, that's that's a good time. That's a really good time. And again, that's a 825, right? This is the G30-825 on a 2.3 liter, uh, with, as you saw, 7 degrees of timing down low. So, like I said, that wiggle could be from weak combustion from not enough timing. That wiggle could be from the dyno trying to control the speed on the rollers, which is probably a good possibility as well. I'm not going to give you the answer tonight because I have to stop. I got some dirty looks a minute ago. So, late on a Friday is not a way to make people, not a way. Uh, yeah. Well, Nolan is the owner of the car, the guy above you there. So he says, be nice to it. So that's what I'll do. Oh, actually, let's take a look at that in the log. Um, let's go back to the engine noise. Yeah, see that difference? That's just, yeah. Yep, yep, yep. That's all I can say. A lot of yips because I'm really excited. And here's the timing. Look at that curve. 7 degrees. That's it. That's all we're running on right now. That's all we got. I'd be interested to see what. Okay, let's do it. We'll do one pull. One pull. One pull. I pull all that timing out of it. Let's throw let's throw a degree back in it and just see where she goes. How's that sound? Does that sound good? I think that sounds good. Let's throw a degree in it. See if we make parts come out of it. No, I'm just kidding. We don't want parts to come out of it. I'm gonna go right here and I'm gonna add 1 degree. Bloop. 0.2. 1.2 degrees right there. And that'll really give us an idea of how far we are from MBT. Like, are we creeping up on it? Are we far away? Like, where are we on this thing? Check my starting real quick. Make sure I'm not post start or anything right now. 0.2, 0.1. Okay, 0, 0, 0. All right, no post start. Third gear, fourth gear. There it is. Oh, I lugged it. Almost nothing. Almost nothing. So it looks like I have the timing pretty freaking close. And if you look, cylinder 2 got a little noisier that pull than last pull. So I would say it doesn't want it. So I would say that our timing was pretty close, actually. Yeah, it probably doesn't want it. Let's see, who's talking shit now? Should be some bit, I would think. 20 torque fingers by, or not. Yeah, yeah. Looks like that was already pretty close to where we needed to be. I went to 9 degrees there and didn't pick up shit. I mean, we did there. Like we did pick up stuff there. Let me do this, hit that, bring up the last two runs, load them in, hit that guy, close there. So you can see it made a difference here, right? Up top it didn't. So up top it already had plenty of timing in it. So my ramp is plenty steep and maybe even technically a smidge too steep because I would want the gap to be about the same. So that tells me that my ramp needs to come down a smidge up top so that the gain in timing or that the effective timing is consistent. So a little less ramp and we'll be in good shape. And then I'll lower it overall anyway. So a little less ramp will knock this down. Um, Hold on a second. Think about this. So if I take a degree out and it stays the same place, then this graph's gonna go to here. So yeah, I gotta lower the ramp. Okay, make sure my brain wasn't wrong here. We added 3 whole horsepower, but we did get from 325 10 foot-pounds of torque. We basically got 10 foot-pounds out of it. That's not enough. That's not worth it. That is not worth it. So let's go back to this guy, back here. Just, right? Go down, 1, 2, and then we go up here, and we go 1, 2, 1, 2, 1, 2, 1. Drop a little bit right here. Or no, half, like that. Okay, there we go. So got that. Do this, like this, go like that, like this, right here, do this, like that. There we go. That's where I'll leave that for now. So I pulled a smidge of timing overall to increase our safety factor since we're on pump gas anyways, lowered the ramp a little bit. So this should make a little less horsepower. I'm not doing the pull on it though, because there's no point, in my opinion. I got the data I needed, like so. Okay. hmm no, it actually hit, what did it get to? 21? So 260 kPa. What is that in caveman units? 23. So 23. That's on pump, and that's with 16% duty cycle? That's weird. That means that his spring pressure is way too high. Yeah, his spring pressure is way too high on this. Yeah, that's way too much. What's crazy is we showed right here how well this engine breathes and how my cams affect the performance of these things. First off, I can't bump this up with timing, right? Like I can't make this look like a 2.5 liter. Like this torque is here. I mean, right here it could use a little bit maybe, right? It's okay. Here it had plenty. So really this thing wants to have a flatter timing curve, as we know. Like I said, they need less ramp. And potentially this is probably fine. The timing I put in here is probably fine. This would be sufficient or too much. So that means that whole curve would be flatter, which on a Subaru is crazy because Subarus usually have big swoopies. But this guy wants a much flatter timing curve than most Subarus. That means good VE up top and good charge motion, um, and which it does. My cams have, I designed them for that, so it's got good charge motion. That's what they're designed for. And then you see it's just climbing. It's still climbing up. Um, and like I said, there's not much I can do to get this higher without just going straight to boost. Maybe some cam timing tweaks, a smidge to get a little bit in this range. Maybe I could add 10, pull 10, see what happens. But for the most part, this sucker is ready just to make flat torque and scream for to 8K. It looks like it'll probably start nosing over around 8 or so. So this is a different engine than a 2.5, right? I mean, that is a different graph. That is a different experience than a 2.5. And I'm a fan. Honestly, I'm a fan. So I love them. I love it. Save that. Everything's working now. I got speed, I got gear selector, I got all my gauges. I've got the converter converting all the EMtron stuff into Haltech data and the Haltech format. So like everything's fucking working right now, and I'm super pumped about that. Um, yeah, yeah, it's really cool. Ethanol will be alright. Yeah, yeah, I think it's gonna be a good time. I'm excited. I'm excited for sure. Oh, also things that will affect that curve: Cosworth intake manifold. Um, a little bit of flow up top, less peaky torque, so that's going to do that too. And it's even crazy is this is on a big front mount and a Cosworth, and it's spooling this fast. That other engine that we had, we have the factory manifold and our top mount air water, and it's spooling it much faster than this, but still, this is fast. Like if you had an ETS kit with this turbo on a 2.5 liter, that's about the spool you'd see. On a 2.5 with an ETS kit, you're gonna see spool around that same area. This is less displacement, spooling it just as fast. Um, and that's going to be the cams really making a huge difference in there, and then the extra compression that this engine has. The other car is a 2.3, spooling it way faster than a 2.5 would, and that's because of the air-water intercooler that we have, low volume, and then uh, and then my cams and stuff. So you can have responsive engines and fast spool and that kind of shit. Yeah, this is a 2.3, dude. Um, we've been doing a lot of 2.3s lately because I love 2.3s. I mean, they're my baby, right? So, but yeah, this is a fucking 2.3. Um, yeah. Yeah, I'm sure you did. The ginger guy's lazy as balls. All right, amigos. Yep, 2-3 makes it more impressive. Yeah, I'm pretty impressed myself. I'm pretty happy with it. So this is my pistons, my rods, my cams, and then I don't remember whose porting this is. Nolan should tell us whose porting it is. Craig assembled the block. Nolan assembled his whole thing. He did his front mount, and I don't know what brand it is, but he did all that work himself. Added a bunch of sensors. I did a bunch of wiring to it, converters, things, much stuff. Like it's really shaping up to be fucking cool, and it's gonna be cool. So, all right, gal, I'm gonna go. It is time for me to dip. I appreciate you all coming by. And again, hit me up in the Discord, shoot me an email, whatever you need, and we can chat if you have any questions about the EMtron, any questions about car parts, if you have any questions about how things run, if you need parenting advice, if you need spousal support advice, if you need to just vent and stuff, I am here. And you can find me on my Discord, and I will listen to your story, and I will give you my input. So have a good one. See you, Jay. See you, Travis.